Okay, so this is the second part. Let me just add some background here. What's a good background? No, this one is better. Yes. Okay, so I want to share my screen, and this was something that I was planning to do with you, but maybe next time. This was to color. Oh, what? It didn't show yet. Yes, okay, now you can see it's a mind map that maybe, yes, I can share with you later the link if you want to add something. But what did you discuss during this course here? It was not only functional programming, but also functions in programming. And then I have discussed in one of the classes the question that sometimes what we say is a function is actually not exactly a function. It's not a mathematical function. For instance, if we have a random function that when you ask for a number between 1 and 100 and it returns, the first time you call it returns 5, and the second time you call it returns 96. It's not a mathematical function. Mathematical functions don't do that. So they are more like relations. But there are some other things that are important for functions in programming. I see there is some message on I hear, no, it's not from you. Okay, so sometimes this is something that it's not that important in mathematics, and even Mateus is not here, but I was not discussing, but talking to him a few weeks ago about the arity of functions in Haskell, because in Haskell, all functions are arity 1. They have only one argument. When you need more than one argument, what do? You just have a function that has one argument that returns another function that takes another argument, and so on. So that's the idea in Haskell. You don't use a function of arity 2 with that. Let me, I'm not sharing my terminal here. Maybe I have to stop sharing the screen and share. That's why I like my sharing the whole screen, because it's easier to. Let me share the whole screen. Yes, here. But I believe I told you that a few classes ago. This is the Haskell interpreter. You know why is the Haskell interpreter is called GHCI? No? It's because sorry?
Something to do with Glasgow.
Yes. Of the GHC, it's the Glasgow Haskell compiler. So GHCI is the interpreter, I believe, for the Glasgow Haskell compiler. So if you have a function f that returns x plus y, and you ask the type for the function f, you see that it's a function that receives a number and then returns another function that receives another number and then returns a number. So I'm not sure what this means here, but it's
a type.
Yes, but why it's a? Because I didn't define it.
Because it's the way Haskell do it. It calls with A, B, C the types. It's not a convention, but it's used this way. If you have two parameters that the compiler infer, you have A and B. If you have three parameters that the compiler infer, you have A, B, and C as types.
Mm-hmm. But what if? No, I don't know Python enough. But the important question here is the type of the function f. It's not. If I wanted to something like this, the type for f now. Sorry, it's something else. Let me just remind me of this. What's the type of this function now? It's only one argument.
A tuple.
Yes, only one argument. In this case, the argument is a tuple. So all functions have arity 1. That's not the case in Elixir. We have functions with arity 1, arity 2, arity 3. I'm not sure if it's allowed in Haskell to have, for instance, and no, yes, I have, when I did this, I have just redefined f. We cannot have a function with arity 2, which it's impossible, and arity 1. In Elixir, we know that it's possible. I can have the same name function. That's why in Elixir, the name of the function contains the arity. So if I go here, one problem I see for beginners with Elixir is that when you have to define a module to define a named function. And let me show here. Def x of x and y is x plus y, and def f of x, it's 2 times x. And let me see. Yeah, so now I have two functions, f1 and f2. It's the same name, but it's not exactly the same name because the arity is part of the name of the function. So yes, one problem, I'm not sure if I can draw a line here between. Yes, that's what I wanted to do. So in Elixir, the arity is part of the name of the function. And we have seen that we can have nameless functions or anonymous functions in Elixir, probably in Haskell too, but I don't know Haskell enough. And it's people in every programming language community that deserves its name agree that you have to give good names to functions, something that for maybe for mathematical functions this is not that relevant. In the case that, for instance, let me write a function here. How do I write? I'm mixing things here. fn. So this is one function. And this is height. No, it's weight. I'm not sure. I believe, because see here, there is a number for that function, a kind of an ID. See, the same ID. Those are different functions for me, maybe for me, but for Elixir, it's not, because the only difference here is the name of the variables. So it probably finds that, oh, there's already a function for that. But my point here is that this is the, sorry, this is the body mass index function. So if I call this a person which weighs 100 kilograms and is 1.7 meters tall, has a body mass index of 34. So you see, I could say that BMI was V2, but it's not the same thing. That's why we define modules and give meaningful. Yes, I wrote here, what's a good name? It must be meaningful. What else? This is not something that I have seen this written. What else is in a good name? Short enough? No, as short as possible. In our case, I, Bruno, Letícia, Pietro, and English is not our mother tongue, right, Pietro? So, Pietro, when you write code, do you when you write code where you work, the name of the functions are in Italian?
Actually, in the last 5 years, I want all the code produced by my company to be in English, the naming, because when you have to, I like to use the software that automates some production, for example, to produce a web API from a structure. If it is already in English, it is easier to swagger the documentation. And so all the code produced by my company is in English since 5 years, I think.
Yes.
But it's the most difficult thing to do, because everyone has his level in English, and sometimes you fight with your colleague about how you have to say something, and it's very complex.
Yes. Well, I write.
It's not just about words, right? It's about metaphors and things. That must be so difficult to do in a second language. I'm sorry for the
yes. Yes, but this is a problem that native speakers don't have, no? Yes, because they have to find. Sorry?
Thinking of metaphors is always.
Yes. But
you end up calling things like manager and rubbish like that if you're not careful.
Yes. Naming
sometimes it's very difficult also in the native language. It depends on the person and the developer, because sometimes the names someone use a phrase, an entire phrase, and someone use FAV and a function very short. So it's very complex. It's a very complex argument.
Yes, naming is a problem for everyone. What I mean is that people in Brazil, I believe, people that work for Brazilian companies, they sometimes, do I give the name to this of this function in Portuguese? Do I name this function in Portuguese or in English? And sometimes people name it in English, but in bad English. So I'm probably guilty of that in my old code. So that's one question. We have seen that modules are they group functions, and this is also a big problem, because it's not only what do I put in a module, but in this module is going to be inside a folder, and so I'm not sure how you can the several ways, but it's the larger task is the task of organizing your codes, and there is a whole area dedicated to that, which is, do you know the name? Structuring your modules and how they communicate in your whole system. Software architecture, or maybe software design. I'm not a specialist in that, but there's the software design, software architecture. So we have just skimmed this because a module contains a set of related functions. And it's funny because in Erlang has I believe it's on Fred Ebert's book. They say, oh, there is, yes, I believe it's here, not here. That's where you work. Where do you work? Oh, yes. So you work with software actors. I thought that you work at Erlang.
No, actually, I am cloud architecture and software architecture as well.
Okay, because there is a company called Erlang Solutions. They are very nice people there. Okay, so I'm not sure I can find, but they have. Oh, usually you give. Oh, sorry, what's happening here? I will not be able to find this now. But they say, no, usually a module contains related functions, but not this module, because this module is the base module for everything in Erlang, so everything is there. A lot, not everything, but a lot of unrelated functions are there. So
I think for Elixir, this is the most important, the most difficult endeavor when you are an experienced programmer, because you don't have any pattern. I only know a book that describe how you can architect correctly a project, an Elixir project. And for me, it was very complex to try to find a way to structure correctly a complex project, because when you have only 2 or 3 modules, this is not the case. But when you have a big chunk of code, when you have an API, when you have something bigger, it is very complex to architect anything, and you don't have guidelines in Elixir.
Yes. See, I believe this is the name of the module. I was thinking it's called Erlang, the Erlang module. If you go to Erlang, if you open the Erlang shell and type Erlang semicolon, this is colon, right? You see, there's term to binary trunk. So math functions are here, and functions related to processes, list to float. So a lot of unrelated functions are in this Erlang module. Types. So we have already seen that there's a lot of material on types, and what's the difference and between static typing and dynamic typing. I believe I didn't cover this well here. But do you have any background on that? Because people say, oh, Elixir is a dynamically typed language.
How? So one thing that confuses me, when I think of a dynamically typed language, I think of Python, where, for example, if you have, A equals 1, nothing stops you saying, then on the next line, A equals a string. But in Elixir, you can't reassign things. So what does dynamic typing mean when everything's immutable? I guess it means it doesn't type check the parameters of functions, or what's it mean?
Look here, Elixir is a dynamically typed language, so all types in Elixir are checked at runtime.
Okay.
So it doesn't. The compiler never complains about types unless you do some type spec, but you see that's not something that's it's that powerful. It's not as powerful as Haskell's type system, which is statically typed. So if I let me try this. Look, I believe this is a good example. I'm going to ask I'm going to define a function that returns its arguments. So I'm going to call this function f. If I call this with a number 90 or with a string Adolfo, it works. Let's try this with Haskell. What's the type of this function? Oh, I believe it works too. So yes, the difference is that in Haskell you probably have a kind of type that it's
yes, when you use the function inside the program, the compiler can infer the type of the function, and when the type is inferred, you cannot use differently. And in the interpreter, you don't have this functionality, of course, because it's not compiled.
Oh, okay. So it's different. Yes, this is something that it's the behavior is different in the interpreter from the compiler.
Yes, if you consider each line as a single program, is the same. But if you have several lines and the context may change. At least I think that this is the behavior you could expect.
And you cannot do something like that in the interpreter, right? To say, oh, the type of this function.
Actually, I don't know, but I thought yes, but maybe maybe no. I don't know.
Yes, I'm asking this because I'm reading a book about Haskell, and it doesn't show this for the interpreter, only for the code. So I'm not sure.
Yes, I think it makes sense if you consider each line a program.
Each line a program. Oh, yes, but can't I, for instance, if I had something like this? Oh, this is this is probably not allowed in Python, but oh, sorry.
You mean a multi-line? A multi-line?
Yes.
I don't know, but I think it would be possible because
multi-line Haskell. Can I write multi-line strings in Haskell? But this is different. Multi-line is another thing. A multi-line string is different from a multi-line comment. Here, defining a multi-line function in Haskell using GHCI. Oh, you can set it. Oh, here it is. Oh, you have to do something like this. So it's so slow. And oh, sorry, I did copy the wrong part. But what I want to do was something easier. Yes. I can copy and paste everything here. Let's see if this works. Oh, lexical error at character age. I believe I know the problem here.
Maybe the wrong character on the quotes.
Yes. But the whole computer is quite slow. Oh, no, not. Let me. And yes. Did I copy too much? No. Where's Haskell? Couldn't match expected type short string with actual type int. Yes, but it seems that, let me try something simpler, because this one was too. If I define this f from int to int, and then f of x equals x. That same example that I did before, just now giving a type to the function. Now let me call f90. It works. Great. So it's possible. So you can define a function with types in. So this is the kind of thing that I believe it's impossible for Elixir. You can't use type specs on IX. So, but my point here is that this is only a small part of types, because there is dynamic, static, there is also gradual typing, and so many things that usually when you are in math, you don't care that much. We have seen in Simon Thompson's talk that you can have functions where the state, you probably did that too in your implementations. I'm not sure, but you have because one of the problems with functional programming is that you don't have a state. And let me just, what's happening here? Okay. You don't have a state, but you can use. Am I frozen? Yes.
Just a little bit slower, but
Okay. Let me. Yes, maybe sometimes the problem is the algorithm for the background. Let me see if I can disable this background. Yes, the whole computer is too slow right now. I can't see you moving, so. Hi.
hi, hey.
So yes, it's kind of restarting here. Yes, I believe now it's okay. Okay, let me see. Yes, no backgrounds. It's better. Okay, so state as a parameter, we have seen that. And higher order functions, we have seen. There are some kind of, I call them famous examples of higher order functions: map, reduce, filter. In Elixir, they are in the enum module, but they can even have different names. I believe in Haskell there are some functions which are fold left, fold right, because it's for a different kinds of reduce. I have told you about functions as being first class citizens, which mean they can be passed as argument, or they can be the return value for some other functions, which can be very useful. And when this part of the mind map, which is called calling a function, because when you call a function, you can call functions in a pipe. Several languages have that. Elixir it was not the one to create pipes. And one thing that I saw some guys discussing on Twitter was that the guy wrote on Twitter that he thought that the best way to call a function should be this one. He thought that. So this would be a kind of postfix function calling. First the arguments and then the name of the function. Usually we do this, right? But when you have a pipe, oh sorry, I missed the dot here. Yes, this is a problem with anonymous functions in Elixir, that you have to include the dot. I have told you about that. But see, first the arguments, then the pipe, and then the name of the function. But I can only do that for functions that have arity 1. If I have, for instance, G is x plus y. Oh, I forgot the ends. How do I never know how to restart everything. G equals Fn of x and y x plus y, and I cannot say, oh, 45, 34, 2g. I cannot do that. I can only do this, but then it complains, oh, you need this. I can do. The first argument is 45, the second argument is 34, and then it sums. But this is ugly,
and
right?
this is why Haskell doesn't have have only one argument, so you can carry everything. And this is very useful when you use applicative monads and other complex data structures.
Okay, good to know. So you can have several options for. Oh, and there is also the Lisp way. Lisp would do something like that, right? First the name of the function, then the arguments, all in the same list. And currying, that it's strange to talk about currying in Haskell, because what you're doing is you're converting a function that receives a tuple in a function that returns a function. But okay, I didn't talk much also here about evaluation strict, because Elixir is strictly evaluated. So there are some modules on Elixir like string that allow some lazy evaluation. Let me just call the help function. String functions for creating and composing streams. Strings are composable lazy enumerables. For introduction on enumerables, see the enum module. So yes,
you can use cycle.
Sorry,
cycle. You can use cycle or the stream. The cycle, with cycle you can produce any number of the product of your function, of your internal function, and I think is quite interesting.
Yes. So basically, what I'm doing here is I'm creating an infinite list. Sorry, no. What's the problem here?
The dot.
Oh, the comma.
Comma. Yes.
Yes, I created an infinite list containing 1, 2, 3, 1, 2, 3, 1, 2, 3, but that's useless. So I have to dot take from that list 3 elements. Okay, 9 elements, 100 elements. So I'm not sure how this works in Haskell, but this is the basic idea, that you create something that can be. So when I created this infinite list here, it didn't put, if I do this io.puts, no, io.inspect, doesn't show anything. But if I take ten elements and then I ask io.inspect, then I can see the whole list. Sorry, the part of the list. So this is kind of lazy evaluation. And memoization. Did you ever do that? Memoization?
Yes, I did something with Angular.
I've done it in Python, but not in a functional programming context.
Yes, it's strange because, yes, I'm not sure. Maybe this could be useful for a more advanced version of the analytic tableau prover, because the idea for memoization is that if there is some function that you can, it has to be a mathematical function, I believe. And
how would you do it? Would you like pass a sort of map along, like tail recursively to each new call or something?
Yeah, so I believe you'd have to do that. And then, of course, the problem with memoization is that if you have a map, this map grows a lot. You're trading space versus speed. For instance, if I have a Fibonacci calculator, and then I calculate Fibonacci 70. To calculate the 7th number on the Fibonacci sequence, I automatically calculate all the others from 1 to 69. If next I want to calculate, I ask this function to calculate Fibonacci 80. If this is already in a map, because this is not going to take so much space. The Fibonacci of 1 is 1, Fibonacci of 2 is 1, Fibonacci of 3 is 2, Fibonacci of 4 is 3, Fibonacci of 5 is 8. I could have a map containing, when I ask the function to calculate this one, I create this map and I get all those numbers. And then when I ask this function to calculate 8, I just have to calculate 80 until 71 because I already have until 70. So this could be a good use of memoization. But yes, I would have to.
A client-side use is for caching.
Sorry?
For caching in Angular, for example, you call an API with the same parameters, and you have the same. You use memoization libraries like a cache, essentially.
You don't. What?
The memoization libraries, like a cache.
Yes. That you mean that there is memoization. It already comes with memoization libraries.
No, you have some libraries. I don't remember the names, but I used to cache the UI essentially. But is used a lot like a cache, and it behaves also like a cache. So memoize something between a time span.
Okay. And of course, when you go to cache, then you have the problems, all the problems related to cache, like caching validation and so on. So, but the basic idea is that if it's something that can be, if you are asking to calculate the same thing several times, it can be useful. And finally, we talked a bit about recursion and tail recursion. There was this, someone was commenting on that, the recursion, continuation, and trampolines. And I have you ever heard about trampolines? I haven't, but there is this discussion here about tail call. That's that thing that when you let me increase here. So in this is an example in Python, you first have to calculate this and then you multiply. But in this example, you call the function and multiply before calling it. So you can how can I say? You don't have to put anything in the stack when you call this function here. But one thing that Simon Thompson told in his course is that Erlang is very optimized so that it's not always necessary to do tail recursion. But there was something.
I think there is something in the Erlang documentation that speaks about this.
Yes, but for instance, this example, Fibonacci, this first version here, which is not tail recursive, is much less efficient than this second version here. I'm going to share this in our, where is our Discord? In the classes channel. Oh, and I'm going to share also this mind map. I believe you can, I'm not sure you can see from with that link. I know it's, yes, share. Anyone with the link can view. Copy board link. So now this is, as you can see, you should be able to see from that link. So did I forget anything important that you remember here? Maybe not. If I did, maybe we can complete this. I will complete this later. So that's what I wanted to show you for this last class. So next class, we are going to present our languages or functional libraries, functional features of some other languages. And in case you have any doubt about what you want to present, just send me a message. Sometimes I'm not able to respond immediately, of course, because I have other classes and meetings, but I promise as we are finishing our course, if I'm going to give you some priority regarding this, okay? Okay, let me just stop this recording.